Hello and welcome to SGN Tech Forum. Last video, we have built a BGP EVPN VXLAN fabric. In this video, we are going to apply a common policy which can help you do your segmentation and policy enforcement end to end. And how do we do that? In Cisco's world, we are going to use SGTs, security group tag, that we are going to enable the support for SGTs within the fabric so that we can apply our policies. If you are new to SGTs, I highly recommend you go to my channel and search with CTS. Here you can see this CTS video related to SDA, software defined access, but it is essentially talking everything about SGTs. That means how you are classifying the tag, how you propagate the tag, and finally how the policy enforcement happens, and what is your data plane and control plane options for propagation. So go ahead and watch this video and come back. So let's do a quick recap. Last video, we verified the fabric because we had this part built, and then we essentially went ahead and added the pieces of configuration or the EVPN construct on border leaf 01 so that it became part of BGP EVPN fabric. That means all the hosts here, they are all part of one VRF campus, and though they are part of different VLAN, they can talk to each other using L3 VNI construct. So now what we are going to do, we are going to see how we can enforce some kind of policies that employees should not talk to IoT VLAN, and how even say you have a requirement that IoT endpoints should not talk to each other, right? So in traditional world, how you can achieve that and what is the new method of achieving this. So let's go to our lab, look at the traditional world first, then we'll come back, revisit this picture, revisit the new technology, what we are bringing in, like VXLAN with SGT support and how it is encoded. Then we will go back and configure our lab for SGTs. All right, this sounds like a good plan. So let's go ahead, log into the lab. Right now, we have leaves and server where everything is connected. So right now I'll show you, we have the server 0, which is in employee VLAN because our subnet is 120, the third octet is 120. You can see this is 120.11 because leaf 1 is .11, leaf 2 is .12, and border leaf is .13. So we have a host machine connected here, and we can go back and ping other VLAN, the IoT VLAN on the different VTAP or leaf 2. We can ping to that by default because we are doing inter VLAN routing. So if you want to stop this behavior in traditional world, there are multiple ways you can do that, but for the sake of simplicity, what I can think of is a IP access list. That means you define your access list and apply it to the interface so that any traffic leaving to that destination will be dropped at the source. And for that, I have already defined an access list. Here, as you can see, we have an access list, extended access list 100, that says from 120 subnet to 180 subnet, deny that traffic and allow rest of the traffic. So where we can apply this, we have our SVI 120, and we can go ahead and apply it as access group inbound. Sorry, we have to give the access group number and then inbound. With this applied, let's go back and revalidate what's going on with server communication. Now you can see we are not getting any reply. That means access list is working. Let me remove this. The moment we do that, you will see the traffic will restore. As you can see, the traffic restored. Right. So this is the traditional way of doing uh, policy or restricting traffic, but this is not very scalable, right? So what you can do, that's where SGTs come into picture. And let me show you what we are talking here. We are talking here VXLAN GPO. Please give this draft a read. This is an old document, but still very valid, very useful. You can see VXLAN group policy option, that is VXLAN GPO, and we'll go straight to the header. This is how the header looks like. So you have bunch of flags, then you have 16-bit of group policy ID, and then you have VXLAN identifier. That is your L2 VNI, L3 VNI identifier, but we are focused into group policy ID. And what is a group policy ID? Group policy ID is a 16-bit identifier that indicate the source group membership being encapsulated by VLAN. So you assign your tag by using any method, static method or dynamic method. And once you assign the tag, that tag is being carried in VXLAN header as a part of GPO. To show you a better picture, I'm going to show you a screen capture from a Wireshark. Here you can see we have a frame captured, a VXLAN frame. Here which VXLAN, you can see we have bunch of flags, and then we have group policy ID. This is a decimal number that can scale from 0 to 65535. That means 2 to the power 16, right? So that's essentially what we are going to do. Now, so you are familiar with VXLAN GPO, we are going to go to our lab and start configuring CTS domain and policies. So here we are in our lab. All the SGTs configuration, they'll be done at leaf, because that's the place where we are classifying and uh, enforcing the policies. Propagation happens as a part of tunneling, VXLAN tunneling. So I'm here on leaf 1. On leaf 1, we have a server connected. So all the TrustSec commands start with CTS, which is shortened for Cisco TrustSec. And you can see there are multiple options here. So first, what we are going to do, we are going to enable role-based enforcement globally, and then we will enable it to per VLAN. So you can do multiple VLAN at the same time. We are doing a VLAN list 120 and 180, because 120 is our employee VLAN and 180 is our IoT VLAN. And just like traditional way, we want to make sure that we can restrict the communication between these two VLAN based on the policies. Next, what we are going to do, we are going to map. Since we don't have any ICE configured, then what we are going to do, we are going to use a static mapping of IP address to SGT. Here you can see we have 10.10.120.11, a server connected. We are going to map it with 120.11. That's the SGT, and we will use one entry for IoT VLAN, though we don't have any server connected at the moment, but it's good for future uses. All right, this is all you need for CTS definition perspective. Then you can verify it via show commands like show CTS role-based SGT map, and you can see whatever mapping we just defined, it is available in show output. So we have .11 120.11 mapped to 120.11, 180.11 mapped to 180.11, and this is coming from source CLI. Remember, please bear in mind you can have multiple sources classifying, so there is some priority for them. You can look at that in our CTS video. Now we have the CTS defined. Let's see how we can define our policy. Here you can see we have an IP access list, but this is not like a standard or extended IP access list, but it is a new kind of access list called role based. All right, so give it a name, employee IoT in this case. And within this access list, you can have all kind of like a regular entries like permit, deny, source, destination, but we are not going to use any source and destination. Hence we'll keep it simple and say one entry, that is deny IP. And it looks like this ACL was pre-configured, hence it is complaining about the duplicate. So I'm going to quickly say no 10 and then go ahead and redefine or uh, define it again, deny IP. Okay, so this is all we are saying, deny IP, but where is the actual permission, right? Where is the source and destination? That thing is again depend on the CTC, because CTC has your personas. So now we are going to say CTC role based permission from what? From SGTs, from 120.11 to 180.12. So at this moment, all we know is a tag. We don't know where it lives. So there are other ways to communicate these tags. We are using static. There are dynamic classification and propagation available also. We will see that in next video. Right now, before we apply the permissions, let's do a quick baseline. That means I'm going to start a ping from server 0, which is 10.10.120.11 to 10.10.180.12, which is on leaf 2. Before we apply the permission, we want to make sure that the communication is happening seamlessly. So let's go ahead, define this permission. So you're saying that from employee to IoT, and that the access list name is employee IoT, which says the deny any communication. So you can see we have the permission in place, and now let's go and see if this permission is actually taking effect and doing what is intended to do. That means breaking the communication from server 0 to server 2 in this case. One thing I figured that what happened is we have not, though we have defined all the CTS configuration, but we have not applied it to our VTEP. And that is essentially an important step. So let's go ahead and do that. By doing that, our CTS configuration will be complete. So it goes into interface virtualization endpoint. Let's see what is what we have configured today. Show run interface NVE1. You can see we have all the member VNI mapped, but we don't have any group policy. So let's go ahead and apply the group policy so that GPO information will be carried as part of VXLAN header. All you have to say is group based policy. That means we want to activate GPO. Okay, this is good. So we have applied the policy, we have policy configured. So let's see if the communication breaks. Let me zoom in a little bit. Right now you can see it is kind of like stuck, but we cannot say because we have just made a change to interface NVE, and due to BFD we may see a IGP BGP drop. So let's wait a little bit and make sure the IGP BGP comes back, and you can see it has resumed the communication. So even though we have the policy at leaf 1, but still server 0 at leaf 1 can go to leaf 2 server 2. So why is that? Let's do some quick check. So another useful command, show CTS role-based counters. You want to make sure that if your policy is getting a hit, just like a ACL, you will see the hardware or software counter increasing. That means your policy is actually in effect and it is dropping traffic. So from 0 to 1 and policy applied at 1. But we do not see any hardware denied or software denied counter increasing. Why is that? So think about it uh, a moment and then we'll discuss. So right now the communication is going on even though we have the policy defined and we have verified that there is no drops or no software hardware denied hits are coming. So why is that? Let me tell you about that. So here on 11, leaf 1, we know who is 120.11, but we don't know who is 180.12. And our policy essentially is saying anything going from or coming from 120.11 going to 180.12. But leaf 1 doesn't have any visibility into who is 180.12, right? So for enforcement, you need to know source and destination tagging. Then only the policy uh, match or policy compare can happen. Here you can see leaf 2 does know who is 180.12 because it is getting that information from device tracking database. As you can see, 180.12, we are learning that via ARP and it is connected to interface 104 locally on leaf 2. So leaf 2 does know who is 180.12 and it does know about the SGT from the static configuration. At the same time, any traffic coming to this VTAP from uh, leaf 1, leaf 2 can glean into the VXLAN header and see the SGT information. So leaf 2 is essentially in a position to do the enforcement. So let's go ahead and apply this CTS permission on leaf 2. So we have applied permission at the wrong place. It should be at leaf 2 in this case. And in you have seen in other orchestrated world like software defined access, these things are all dynamically happen. It's all orchestrated. That means uh, leaf can go and fetch those policy where it is itself is a target or as a destination. So let's go ahead and apply the policy, right policy on leaf 2. We are saying that anything coming from 120.11 should be dropped going to 180.12. This is the policy, essentially the same policy we applied at leaf 1, but it didn't work. So we are going to apply it on leaf 2. Role-based counters. All right. I think it's our IGP, BGP is still getting synchronized because every time you make changes, there are some drops. So let's be patient here. Let's make sure that we have the group policy object on NVE. Yes. So we have all the essential configuration. Still, we are not getting any hit. Let's go to server 0. It looks like it is stuck. Let me cancel it and restart. You can see we are not getting any ping reply. But we cannot say for sure if it is like transient thing because IGP was down or is it really role-based policy. Give it a moment. Yes, you can see we have hardware denied 12. So we are getting matches, right? And On server 0, the ping is going on. It is continuous ping, so it's going on. So that means we should get this hardware denied counter increase more and more. Give it some time, or let's check one more time. As you can see, now it's increased from 12 to 52. That means our policy is really working and we are getting the matches, because we have a policy which says that anything coming from leaf 1 server 0 should going to leaf 2 server 2 should be denied based on the source and destination tag. And leaf 2 does have destination tag information uh, as a part of static mapping, and it can see the source tag coming in from VXLAN header. So essentially, this is how you can apply security group tag to create segmentation. In this video, we are showing only one subnet to another subnet restriction, but it doesn't stop you doing it for the same VLAN. Or you can even say that from and to is the same tag, but your policy is actually restricting that. So that is also a possibility. You can be creative. You just don't have to say permit and deny, but you can be more granular and specify upper layer protocols as well. So that's how you can control your policy. I hope this video was informative and you like the video. Please do like, share, subscribe, and I see you in next video. Thank you.